The water collection station in Senior Cornelis Biemon near Breukelen in Holland. 150 million cubic metres of water from the River Rhine are collected and purified here annually. From Breukelen, a single and more recent 35-year-old twin main runs to the dunes on the coast in northern Holland. Part of the pre-treated water is filtered in the dunes for a period of 3 months to be used for drinking water, and part is supplied to major industrial clients to be used as process water. At Breukelen, the twin pre-stressed concrete mains runs between the Amsterdam-Utrecht railway line and the A2 motorway. Great changes in the area are imminent. The railway is to build 2 embankments for the planned high-speed railway line, and additional lanes will also be added to the motorway. The 35-year-old twin mains were not designed to cope with the new situation. Subsequent ground movement could result in joint failure and leakage. To solve the problem, and at the same time minimise the effect on hydraulic flow, it was decided to insert a flexible, thin-walled polyethylene pipe into the existing main, using Subterra's patented subline close-fit relining method. The design required a 1174mm SDR61 polyethylene pipe to be used. In consultation with the water company, consultants, contractor and Subterra, a test programme was drawn up to verify that the installed liner pipe would last a minimum of 50 years. A number of research institutes and laboratories throughout Europe were involved in the tests. Important considerations were the long-term tensile strength and the effect of possible damage to the liner pipe surface. A series of tests was carried out in accordance with European and international polyethylene pipe standards. The tests showed that the material was not adversely affected by the subline process and had a life expectancy of more than 50 years. The worksite near Breukelen is so waterlogged that grass almost seems to float. Sandy tracks were laid for the construction traffic. Every 350 metres, sheet-piled excavations were built to allow access to the mains. Water was everywhere, not just inside the mains. Literally a question of pump or be flooded. The polyethylene pipes were supplied by leading plastic pipe producer Pulver Pipelife. With their long-standing expert knowledge and experience with plastic pipes, Pulver Pipelife were important members of the project team. The 1174mm diameter, 24-metre long pipes were produced in Germany, one of the few places where equipment for manufacturing pipes of this size was available. The pipes were transported by road to the worksite, a distance of some 300 kilometres. They were unloaded at 2 depots that may appear almost next door to each other, but are in fact a 25-kilometre drive apart because of the complex road and rail structure. Up until the Breukelen project, the previous largest diameter subline project involved the lining of a 900mm gas main in Manhattan, New York. Extensive consultations between the water transport company Rhine-Kennemerland, Nelis Infra, Etasol and Subterra showed that relining 1200mm mains was feasible. Nalis Infra and Atasol together, with technical support from Subterra, planned the execution of the work.
WRK met Knoester, goedemiddag. Hallo Rob. Hapkoude A3 dicht. Oké, komt voor elkaar. Rob, hoi.
The moment has come for the first of the two parallel transmission mains to be shut down at the Nieuwegein location. The real work had started. First, the eastern main was broken open. Meanwhile, work had already begun on butt fusing the polyethylene pipes together. A marquee affords protection from air-blown dust and adverse weather conditions. After the pipes have been aligned, the ends are brought together. A rotating smoothing plane ensures perfectly parallel pipe ends. The heater plate is slid between the pipes and the ends brought together. Both pipe ends are heated until they have the right plasticity. This takes about 15 minutes. The heater plate is removed and both pipe ends are pressed together. The resulting joint is as strong or stronger than the pipe itself. The joint is allowed to cool for 30 minutes and the clamps removed. The external weld bead is removed and the job is done. In this way, pipe strings with a working length of typically 350 meters are produced. The pipe string is then fed through the special subline machine. Gripped by enormous jaws, the machine pushes the liner pipe through the folding guide, which folds the pipe into the characteristic heart shape, reducing the cross-sectional area by up to 40%. Polyester banding keeps the pipe folded. The 350-metre long sublined pipe is now ready for insertion. A towing nose is fitted and the drawing cable attached. Slowly the sublined pipe slides into the concrete water main. Pulling forces are low. No more than 10 to 15 tons is needed to draw the pipe through the main. At the reception pit, 350 metres further along, the polyethylene pipe emerges undamaged. First, the pipe ends are restored to their original circular shape. Viking Johnson liner grip fittings with pre-drilled blank flanges are fitted to close off the pipe temporarily for the liner reversion stage of the process. From the main still in operation, water is taken to fill the newly inserted liner pipe. Water pressure is raised, causing the retaining bands to break. The polyethylene pipe resumes its original shape and fits tightly inside the concrete main. Relining the first 700 metres of the eastern main has been a success. It took a 25-kilometre detour to transport all equipment to the southern work site to complete the relining operation. One of the two mains had to keep operating. Once work on the first main was finished, the same procedure was followed for the second one. The concrete main section that was removed to facilitate the lining process is now restored. A watertight fit between the concrete main and the polyethylene pipe is achieved using the liner grip fittings. A tank supplies water to clean the renovated main before putting it back into service. The subline method was specified for this project, not only because it was the most economic solution, but because the water transport company Rhine-Kennemerland was keen to adopt the latest technology for water mains renovation. The project has set a new standard, the world's largest close-fit lining project, achieved by inserting a polyethylene pipe with a diameter of 1174 millimeters using Subterra's innovative subline method. The client's confidence in this technique and the expert knowledge of the contractors have produced optimal results.